diesel engine has been in use for almost 100 years. But on the roads, it's tended to be used mainly in lorries, buses and taxis. The public image of the diesel engine has been that it is noisier, smellier and smokier than its gasoline-burning equivalent. But modern technology is transforming this image. Today, there are many motor cars powered by quiet, clean, high-speed diesel engines. And they are achieving far higher levels of fuel economy than are possible in gasoline engine vehicles. To appreciate why this change has occurred, we need first to understand how the diesel differs from the gasoline engine. Both diesel and gasoline car engines use the same four-stroke cycle: induction, compression, power, exhaust. But in the diesel, the induction stroke draws only air into the cylinder, not a fuel-air mixture as in a gasoline engine. This air is then highly compressed, which heats it to around 550 degrees Celsius. Towards the end of the compression stroke, the diesel fuel is injected into the combustion chamber at very high pressure, over 350 bar. The atomized fuel mixes with the hot air, and ignition occurs spontaneously. Hence, the diesel is also known as a compression ignition engine. No spark is required. The expanding combustion mixture now forces the piston down, producing power. The exhaust stroke drives the spent gases out of the combustion chamber. The diesel's increasing popularity with motorists is based on its economy and reliability, both consequences of the compression ignition principle. Take reliability first. To achieve combustion, we saw that it was necessary to compress the air a great deal to raise its temperature. The degree of compression, or compression ratio as it's called, has to be much higher than for a gasoline engine. So the diesel must be built to withstand these high pressures, and this tends to make it more rugged and reliable. In addition, the fact that no spark is needed means that the engine is simpler. There's no carburetor, no electrical ignition system, distributor, spark plugs and so on, which are often the cause of problems in gasoline-driven vehicles. Now let's look at fuel economy. At full power, there is little difference between diesel and gasoline engines. But as the power is reduced, the diesel starts to become more efficient than a gasoline unit. This is because power is reduced by decreasing the fuel flow into the engine, which lowers the proportion of fuel in the combustion mixture. This improves the efficiency of the engine, particularly at the lower speeds common in city driving conditions. The gasoline engine, on the other hand, reduces power by throttling a virtually constant mixture of air and fuel. The other big saving comes from the rapid warm-up of the diesel engine when starting from cold, as compared to the gasoline engine, which can take up to 15 kilometers to reach its optimum fuel economy condition. When many people only use their cars for short urban journeys, this can make a big difference. To benefit from the inherent efficiency of the diesel engine, it is important that the fuel system delivers exactly the quantity required according to engine conditions. The main components of the fuel system are the fuel tank, a filter, the pump, injectors, and a return pipe to the fuel tank. At the heart of the system is the pump, usually a rotary pump, and it's an expensive piece of precision engineering. It has to deliver a precisely metered quantity of fuel to each cylinder at pressures of over 350 bar at exactly the right moment on the compression stroke. Often the fuel must be injected within less than 1/1000th of a second.